Hi guys, Buildzoid here, and today we're just going to do a teardown video of this here HD 5870, and we're going to see what we can see and maybe ask Google a few questions about what we see. Yeah, so this is an HD 5870 Vapor X because, I mean, in the last video I said it, I'm a huge Sapphire fanboy, and so I have to, so I'm kind of collecting the Vapor X cards. I'm also kind of considering getting the RX 590 Gold Edition, just because it's gold. Like, I know that's a really stupid reason to buy a card, but it's like, well, it's a special edition and it's made by Sapphire. That's a reason enough for me to start considering buying it. But currently, I think it's a bit too expensive, I think. So anyway, let's take this apart. So I had no idea this comes with a backplate. That was actually a really pleasant surprise. The overall conditions. So obviously, I got this off of eBay, and I gotta say, and I haven't even turned it on yet, but the condition's pretty good. It's not anywhere near as dusty. Actually, I'd say the condition's really good. Like, the only issues are like the cracks in the plastic we have around here, but that's just the shroud. So I don't know. I might just put some glue in there so that doesn't potentially get worse over time or something. I mean, I'm not sure I even care that much. Like, it's really, really minor as far as I'm concerned. The card itself doesn't look like super dusty like some cards I've had where it's just like my 290X Matrix was disgusting, to put it simply. And I also had one card which belonged to a smoker, and that card still smells a bit like cigarettes. And so that's, I think, the worst condition card I ever got. So, okay. So at this point, the heatsink should come off. I think, yeah. Up. There we go. That was nice and easy. Thermal paste looks fresh, so I assume yeah, that doesn't look very old, does it? Yeah, no, that looks, yeah, that's fresh. So that's fresh thermal paste on there. We have the Sapphire, stylized inductors. It doesn't really, right, just a little bit of finnage to them. 4-phase V-core. I think that's memory power, and I think this is memory controller power. I'm not 100% sure. I'd need to grab the multimeter to check. Anyway, well, capacitors. I can't... Okay, this is a brand I don't know. Great, I love that. It's really, like... there's only a few capacitor brands which are, like, easy to identify because they have logos and... or because they have a very specific, like, part number. So, like, Nichicons are easy to identify because you have an FP... and then an hours rating right after that. That's one thing I always wonder about with these old cards is just like, well, this is so old that the capacitor's degrading is a potential actual concern. Right, come on. There we go. And we do have some, nice heatsink, a decent heatsink for the VRM. I actually call that nice. That's more substantial than what I've seen on some modern cards. And I am going to grab the multimeter because I do want to do some measurements. There we go. Multimeter's here. And we're not going to do them right now. I'm just going to take the card apart first and then do measurements. But I want to check, like, where's memory, where's V-core, that kind of thing. Though I think this is probably memory because that, well... That's always the thing, is like AMD's memory controller tends to actually pull more power than the memory itself, or at least need more current. So, it's like if you look at the memory system on like a HD 7970, I think the whole thing pulls like 35 watts under load, and 15 of those watts go straight to the memory controller. They don't actually go to the memory chips themselves, just memory controller. So, yeah. Or it's close to 15. Like, it's really imbalanced in favor of the... Okay, wait a minute. Just gonna check. Okay, that does not go through the backplate, so we're not going to worry about that. And this one does. Oops. And come here. There we go. So, a little bit dusty. And let's see how... Is there more thermal pad? I don't think so. Oh, there is. Unless I missed a screw. No, got that one, got that one. Got. And these just go straight through, so those aren't a concern. Oh, yeah. Oh, there's more memory on the back. I think... Wait a minute. Does this mean this is a 2 gig? This might be a 2 gig. I don't... That's awesome. I thought this was a 1 gig or something. What? Uh, okay, so this shows how much I don't know about 5870s. Fun fact, I have 2 of them, and I have benchmarked it on benchmarked one of them on LN2. And so this third one, I wanna run 3-way crossfire with these. Because 5870s. Also, I want to, like, my first 5870, the one I ran on LN2, has a problem where once you raise the core voltage too high, it like micro throttles or something. Like, it scores really, really badly. So yeah, the clock's like it basically just stops scoring properly. So because of that, I've kind of been like, gonna pick up more 5870s until I find one that doesn't have that issue, and that would be really, really awesome. But are these 0.5 millimeter? Oh yeah, that's 0.5 millimeter. That's really thin. That's a 0.5 millimeter thermal pad on the back. I guess we could just check the... Like, I'm not seeing any part numbers on the PCB itself. Did I miss one on the... Like, not anything that would quickly tell us what it is. Yeah, no? Oh, it's on the shroud. It's right here. Yeah. 5872 gig. Oh, it's toxic, actually. Awesome! So... Yeah, toxic HD 5872 gig GDDR5. You'd have thought they'd leave like a toxic sticker somewhere on this. But yeah, this is more special than I expected. I thought it was just a generic Vapor X card, which I thought they made a couple of, but no, this is a 2 gig HD 5870. It's pretty cool. I didn't really like, I don't know how these compare in terms of memory overclocking. The memory chips are Samsung. So that might be a good thing, might be a bad thing. I don't really know, who at the time that these were being produced made the best memory chips. So yeah, it's kind of unfortunate that I don't even know like if this is good in terms of memory or bad in terms of memory. And for the voltage controller, we have a UPI semiconductor, so that's going to be fun to get a data sheet for potentially. And what is it? So 6213A. So let's throw that into Google. It'll probably tell us that it doesn't exist, but we can try. UP6213A. Oh, I am in luck, I think. Datasheet download for 6213. Oh, hell yeah, I am in luck. 22-page data sheet, UP6213. Lovely. Awesome. Okay, so what does the data sheet tell us? Selectable phase number of operation, 613A is 3-4 phase, 6213 is 1 or 2 phase, 8-bit DAC, VR10 and VR11 support, so that's the Intel voltage regulator standards right there. Programmable dynamic power saving mode operation, simple single loop voltage mode control, lossless RDS on, current sensing for current balance. Neat. So this uses low side MOSFET. I think low side MOSFET current sensing. Adjustable operation frequency from 50 kilohertz all the way up to 1 megahertz per phase. Whoa, 50 kilohertz is low. I guess. Like, when was this thing... Oh, well, it is VR11. So, yeah, I guess that makes sense. Because the thing is, as time has progressed, one of the biggest improvements in power MOSFETs is that they are much, much faster to switch on and off. And basically that means if you have a power MOSFET that takes a month to turn on and off, you really don't want to be turning it on and off several thousand, hundreds of thousands of times per second, because every time you go through that, turning on sequence and turning off sequence, you burn a whole bunch of power because the transistor's resistance is not infinite and not zero, right? So, or not RDS on, so it starts climbing up and down. If you're turning a high side MOSFET on, your resistance starts falling until it hits RDS on, and then once you start turning it off, it starts climbing back up to infinite, like theoretically infinite, right? Like when it stops passing any current through. And yeah, well, during that, change in resistance, if that takes a very long period of time, you have a much larger amount of power loss going on through the MOSFET. So that's basically where you get all of your switching losses. And so if you have a MOSFET that's really, really slow to switch on and off, you burn a whole bunch of power. And the way you can sort of work around that is to have a really low VRM, like per phase switching frequency, because you incur that, switching loss, say at 50 kilohertz, you'd incur it 50,000 times per second instead of, you know, like some most modern VRMs will default to like 300 kilohertz. So you incur the power loss 50,000 times per second instead of 300,000 times per second, right? Which is a pretty major difference if that is a major problem with the MOSFETs you're using. And these are power stages, I think. Well, they're a type of power stage because that is obviously not a bunch of separate MOSFETs. So that's pretty cool. What are these? Oh, these are from the Renaissance? These are huge. I can't read the part numbers. Okay, so there's a little trick you can use to try get part numbers to highlight. You can dab a little bit of thermal paste on them. And I'm just looking for a rag that I use for cleaning thermal paste so I can do that. Oh, there we go. Nope, that's just ink. Okay, that's wrong piece of paper. Whatever. I mean, we can just use the thermal paste that came with the card. Now if we go over the chip. Okay, so right now it's just white, but... Because the thing is, the part numbers are actually engraved, so if you do this, you'll embed some of the thermal paste in the part number, and the part number will then become lighter and theoretically easier to read. Which also kind of depends on how deep the engraving is. You can also try use like Scotch tape does can achieve the same kind of thing, but thermal paste is on hand, right? So it's a bit more legible. Actually, that's a lot more legible. So that is a R2J20602. R2J2. Sounds a bit like R2D2. So R2J2. What was it again? 0602. Okay. Okay, well, I can buy these. That's nice, but I wanted to... Okay, Mosfet Driver 40 amps. Okay, it is mislabeled. So it is a 40 amp power stage. Or DR MOS. I assume... Yeah, okay, that would actually make sense that it's DR MOS, because that would be dumber than... Well, that's still a type of power stage. No data sheet? Really? PDF? Nope. That doesn't work. Doesn't work either. Okay, we're going to have to go straight to... I'm going to go to the Renaissance website. Oh, no. Google's just freaking useless. Found it. Okay, well, that's not actually a data sheet. So R2, yay, found it. I think. There's a whole bunch of, like, different variants of these. There's, like, no, that's the same thing. I don't know why they have it twice. Yeah. Multi-chip module incorporates a high-side MOSFET, low-side MOSFET, and Mosfet Driver. So yeah, it's typical DR MOS or power stage. In a single QFN package, on and off timing of the power MOSFET is optimized by the built-in driver, making this device suitable for large current buck converters. The chip is also this chip also incorporates a high-side bootstrap Schottky barrier diode, eliminating the need for external SBD. Neat. Okay, I don't really care. Do we have efficiency graphs? We do, I think. Yeah, I found them. Output current. Oh boy. Okay, yeah, that's kind of what I was expecting. So, normally if you're looking at a 40 amp power stage, you don't really, like, a lot of, like, modern 40 amp power stages are much smaller than this. This is actually, like, this is bigger than a 70 amp power stage. And part of that is because this, if you push 40 amps through this chip right here, it's going to produce, okay, so what's that? Yeah, for 1.3 volts output. Oh, and 1 megahertz switching frequency. So that's actually straight up maxed out. That's actually really, really high. But yeah, 1 megahertz switching frequency, 1.3 volts out, 12 volts in. And this thing is going to produce almost 11 watts of heat. So, and I assume that's what they intend to run it at, right? Like, is there an efficiency? Oh no, that actually, yeah, normalized power loss, 1 megahertz. So if you run it at 500 kilohertz, you can cut down that power loss to like 0.7. So if you ran 500 kilohertz on one of these, so I actually wonder what Sapphire runs these on. It would be cool if we could change the switching frequency, because obviously Renaissance seems to think, like, knock yourself out, run a megahertz through these. Which, with GPUs, cranking up the switching frequency can oftentimes give you really, really significant core clock gains. So, yeah. What are we looking for? 500 kilo, yeah. So, what is it? Almost 11 watts times 0.7, because it's a relative curve. Yeah, so we'd be looking at around 7.7 watts per power stage at 40 amps output, 500 kilohertz switching frequency. So I really wonder what the switching frequency on these is. The inductors are, so if we look over here, we can see that the inductors are, focus, damn it. Oh, there we go. So yeah, those are MR30, and what that tells us is these are 30 nanohenry inductors. 300 nanohenry inductors. And, well, that's actually not that far out of the norm for modern GPUs. Like, modern GPUs will be like 220 nanohenries or lower. And the reason, again, like, the reason why you'd have a really high inductance on old voltage regulator designs is because you couldn't run a stupid high switching frequency. So if you ran a really high switching frequency, your MOSFETs would be burning a ton of power for no good reason. And the thing is, if you have a low switching frequency, you need a very large inductor with a lot of inductance, because otherwise you get a ton of output ripple, right? So yeah, but this is actually, like, this is not that different from what I would consider like a modern VRM. So I like the build quality a lot. Also, we do get the little heatsink. The heatsink will work great if I run the card on LN2 or Sub-Zero, because it isn't dependent on the rest of the cooler. Which, like, that's one of the things that annoys me with a lot of the modern cards. Like, I get that integrating the VRM heatsink directly into the GPU heatsink does make the VRM heatsink a little bit better. But then it's like, when I want to run LN2, how do I cool my VRM, guys? I don't have a heatsink. Yeah, so that's a nice little, 160 amp VRM, which is actually, that's a good amount more powerful than I think you need for a 5870. These pull a surprisingly low amount of power when you're overclocking them. Like, I remember when I overclocked my first 5870, I was really surprised that it wasn't burning as much power as I was expecting. So next, let's take a look at that. Back to the datasheet for the NCP voltage controller, because I want to know if we can change switching frequency. Is there like a whole bunch of programming pins? Bunch of vid, we have, yeah. Like, this thing goes up to 1 megahertz, so we can, like, these support 1 megahertz, the controller on the back supports 1 megahertz, we can totally run 1 megahertz, right? Nope. Let's... The automatic phase switching and no. Switching, oh, okay, so there's just a resistor. Shows, kilo ohms. So if we go with it doesn't even go to it doesn't go all the way up to 1 megahertz. It seems to go to like 800 kilohertz, but that's still a lot. Like, that is very, very high. Now, if I could just find the application diagram, that would be great. Okay, yeah, so there's a pin called RT, and RT sets switching frequency. Come on, where is it? There, switching frequency programming, connect a resistor from this pin to ground to set the switching frequency. Yeah, so that's going to be super nice and easy, especially since the controller works less resistance, more frequency. So yeah, there's going to be a resistor here, and we can just put a resistor in parallel with that one, and it's going to crank up the VRM switching frequency, which is really, really cool. Obviously, that's going to make the VRM burn more power, but I believe in the heatsink, and I believe in the Renaissance 40 amp power stages. So yeah, if we can crank up the switching frequency, we shall. So yeah, that's fun. And now let's check out. Like, I want to figure out where the memory VRM is and where the. Like, I still think I'm 99% sure this is memory controller, because that's, I think, how AMD GPUs are normally done. But it has been it's been ages since I've looked at a 5870. So basically, I'm just looking for resistances. I'm not actually sure what the resistance on this is supposed to be. Hop. Like, whichever one of these is lower is memory controller. So that's 38 ohm. Can't see anything. And still can't see anything because of the glare. Nope, that makes it worse. Hop. It's still pretty bad, but... Go. Huh? Yeah, so... Yeah, it's 38 ohms. And if we go to the other one... That is 16 ohms. Okay, so... Results are inconclusive. I think it's probably down to the fact that this has so many memory chips, because if you actually put more memory chips in parallel, it drops your memory rail resistance when it's turned off. Yeah, so that's 16, which... Yeah, that's just straight 16 ohms. So I'll have to run this card and check what voltage is coming out of here and what voltage is coming out from over there, because then it's really easy. Like, if this is memory power, this is going to be outputting like 1.55 volts. And if this is memory controller power, then this should be putting out, I think, around 1.1 or around 1 volt. So significantly less voltage than the other one. Anyway, I mean, we can also check the core resistance just for fun. What is it? 1 ohm. That's pretty low. That's pretty low, but that is not concern-worthy for a GPU at all. So, yeah, interesting little card here, isn't it? I'm excited. So... Because it looks like this thing will, like, I'm not sure if we'll have software voltage control, and I'm not sure I even care if we have software voltage control, because I can do, like, if I can hard mod the switching frequency, I'm happy to hard mod everything. It would be nice to be able to mod the load line calibration as well, which I think there's, like, we have a 22-page data sheet. If there's a load line calibration set, like, if there's a load line, then we can change that as well. I have a massive video table that I don't care about. Oh yeah, there's a resistor that controls droop. Yeah. Where VADC is slew rate limited voltage source, I average is current source proportional to output current, and RDRP... So RDRP is an external resistor for adjusting load line slope. Yay! So we can tweak the load line, we can tweak the switching frequency, we can change the voltage up, down, left, right, center. Well, okay, that's not actually true. You can't shift the voltage side to side, but yeah, we can tweak everything on this thing. So this is going to be exciting. This is like this thing is, well, like, we have a lot of control over this thing physically, which is really, really nice. So we can crank up the switching frequency way up. Yeah, I'm excited to work on this thing. Now, the thing is, with the backplate, it's just like, yeah, that's not gonna fit anymore. Probably gonna, like, I guess I could, like, chew out the end of the backplate to make space for the mods, because, like, all the mods have to start right here, and then this has a lip, right? Like, there's an edge to that. So, unfortunately, we can't just whack a bunch of mods on there and ignore the fact that the backplate exists. So if I want the mods to clear, then yeah, I'll have to, like, I'd have to cut a hole in that, and I'm not sure if I want to. And it wouldn't necessarily look bad. It's not like there's too much, like, going on with this backplate, right? Like, it is just a metal plate. So, And then for mods, I mean, the backplate actually gives us a lot of, like, if I'm just going to add multi-layer ceramic capacitors, we have tons and tons of space to work in. We actually have a whole bunch of pads already pre-prepared for that. So that's nice and easy to work, nice and easy to do. I assume this is going to be a voltage controller. Now, if I remember correctly, modding memory voltage on my other did I actually do that? I'm not sure. But 5870s, like my previous experience with 5870s is that the memory does not overclock very high, so, you know, maybe that, like, this could be better just because it's on Samsung. Like, I don't even remember what memory chips the other ones are on. But, yeah, I'm really, like, I'm excited. Like, first of all, this is the actual Toxic Edition. It's not just a regular Vapor X. This is the 2 gig. And I did get it really quite cheap. I think it was like, well, 17 quid for, I think it was 17 quid total. So something like, I think I paid like 15 for the card and then 8 for the shipping, no, 3 for the shipping. So yeah, like ridiculously cheap for what it is as far as I'm concerned. Like I've seen like other special edition, you know, Sapphire cards going for like way more than they're worth as far as I'm concerned. And people would still pick them up. So I'm surprised that I got this as cheap as I did. And this is exciting. This is a nice card. So, yeah, new toy for me to play with. And I'm probably going to take this Sub-Zero, but before I do any of that, I do want to run it in like 3-way and 2-way crossfire with my other 5870s. I really want to figure out if this also has that same weird issue where it's just like once you raise the voltage too high, you lose a bunch of performance. Hopefully this doesn't do that. If it doesn't do that, that would be awesome, because that means, you know, I can run it like way higher than the other cards on LN2. So, yeah. Man, I kind of feel like just picking up a bunch of these toxic cards if I can find them. Like, assuming the memory, like, I'm hoping that there's no, like, it's also possible that with 2 gigs of VRAM, this will actually clock memory worse, but it shouldn't necessarily, because the way GDDR5 implements multiple sets of memory chips on the same memory interfaces, they actually cut down the memory interface. So, like, if you're looking at DDR4 or DDR3, they have multiple memory ranks. Here, a single memory chip has either a 32-bit memory interface or a 16-bit memory interface. So when you have a card like this, where you have, you know, 4, 4, and then another 4, 4, which like another 16 memory chips in total, which works out like if you were using 32 bits per memory chip, that's 512 bits, which obviously doesn't fit onto a 256-bit memory controller of the 5870. But with a what is it? But with clamshell mode, each of these actually just runs as 16 bits. So it shouldn't really put any extra strain on the memory controller, and it should just mostly be, like, I'm not even sure it strains the memory power delivery that much. So, yeah. Exciting little card. Oh, I guess I could have just checked the bulk capacitors by the memory chips as well. It's another option for figuring out which of the, well, not bulk, but the larger multi-layer ceramics by the memory chips for the memory rail, but, yeah, so I will give it a bit of a clean, because as you can see, it is a little bit dusty under where the backplate was. But man, I'm really happy. And then of course, I think most people probably are like, yeah, and of course the card gets the whole Vapor X branding, because there's a vapor chamber in there. You can kind of see it there. You can see the fill port almost down here. Like let's see if I can get that on. Well, the fill port's over there for the vapor chamber. So that's where they fill it up and then weld it, I think, to close it off. And yeah, you have some... what are these? These look like... These thermal pads look like they might be a millimeter, not 0.5. So yeah, I'm obviously going to replace everything on the card. Just clean it up. This is peeling off. We don't need that. There. Shroud's a bit dusty, but really not that bad. So yeah, I'm really happy what I've managed to pick up here. And I'm super excited to overclock this, because the 5870... Well, yeah, the 5870, like, it was fun until I realized that I had voltage issues, right? So if this doesn't have voltage issues, this is just going to be fun, period. No until voltage issues or anything like that. This is just... This looks like a fun card to work with. So, yeah, I'm excited for this thing. Anyway, hopefully this was somewhat interesting. Damn it, I don't have anywhere to put that down. So yeah, hopefully this video was somewhat interesting, and thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Teespring, I have Patreon. So Teespring has a bunch of merch like HOC shirts and socks and posters. And then of course the Patreon is for people who don't want to buy anything. You can just support me directly through Patreon. And yeah, that's it for the video. So thanks for watching, and goodbye.